In this lesson, we're going to look at Pythagorean theorem. So our goals today are to identify the hypotenuse of a right triangle, use Pythagorean theorem to identify right triangles, and apply Pythagorean theorem to solve for side lengths. So we've got three main objectives. All of them are quite simple. This is a little shorter lesson, a little bit of algebra involved, but I think it should go fairly straightforward for you. So first of all, what is Pythagorean theorem? Well, Pythagorean theorem was discovered by Pythagoras. I believe he was a Roman, he may have been a Greek, not that that really matters. And what he discovered was that if we could take the square of each side of a triangle, so imagine you drew so I don't have this drawn in the right orientation, I'll draw a little triangle over here. So let's just say that we could draw a triangle. Okay, so there's our right triangle. And what Pythagoras said was, he says, if you could take a square off of this side and a square off this side, so the two non-diagonals, and you add those together, you will get an area equal to this a square based on the third side. So that's what his formula came up with. He says, if we take the square of the two legs, a squared plus b squared, it will always be equal to the square of the third side. Now, we got to think about a couple key things. First of all, this only applies to right triangles. So you must have a right angle. If it's not a right triangle, this relationship will not be true. So we're required to have a right angle. C is always and will always be the hypotenuse. So the hypotenuse is the side that's opposite the right angle. Okay, it's always the longest side. Okay, it will always be the longest side and opposite the right angle. So being able to identify where is the hypotenuse is going to be really important for the rest of this lesson. Now, in terms of A and B, which one is which? It doesn't matter. The other two sides, I could have put A on the bottom and B on the vertical side, and I would still get the same answer. Well, why? Well, if you're adding things, it doesn't matter which order we add them in. And you'll notice A and B get added together. And that's why it doesn't matter which one's labeled A and which one's labeled B, as long as C is the hypotenuse, and it can only be the hypotenuse. So one of the things that they often use in trades, I'm not sure if it's used as much for your trade, but you could use it just as effectively. I do know it's used extensively for carpentry and those kinds of things, is the Pythagorean triple. So we're going to do a couple exercises with Pythagorean triple, and then we're going to go back to using the equation. So what Pythagoras said was, he said the triangle, the smallest triangle that would meet his conditions for the equation of a squared b squared equals c squared is a triangle that has a 3, 4, 5 side ratio. 3 squared equals 9, 4 squared equals 16, and then if we check 5 squared equals 25, which happens to be 9 plus 16. Okay, so this is the Pythagorean triple. And he discovered that any triangle that has that 3, 4, 5 side ratio must have a right angle. So we can use that as a test in carpentry. What they would do is, you might have a wall, or you might have a room, and you would measure 3 feet on one side, 4 feet on the other side, and you check to see, is the diagonal connecting those 2 points equal to 5? If it is, you're square. If it's not, you're not square, you need to square up. So that's one of the places where I know it's used in terms of machining. I don't know if you would use it to check a right angle or not. It is one of our outcomes, so we are going to do a check on that. But you can let me know if you think it would be helpful, or where you might have seen it. I would have a tendency to think if you were machining something, you would just take a square and put a square up to it. That's not as easy when you're trying to check is something square over a larger distance. But for smaller parts, it's quite straightforward just to pop a square on the corner. All right, so using the right angle ratio, I want to know, I've got 4 triangles listed. We have their legs listed, we have the diagonal listed, and I want to know, is this corner going to be a right angle? It's really simple. We're just looking for, really what I'm asking for is it a 3, 4, 5 ratio? Okay. So we're looking for, is it a 3, 4, 5 ratio? It'll take me a little bit to get back to writing virtually with my pen. So the first thing up, we look at the first one we have, 18, 24, and 30. I'm going to change colors here, go a little darker. So 18, 24, and 30. Well, let's reduce them. And the largest thing that I can divide all 3 of these by, you could divide them each by 2. But I happen to recognize I can divide each of these by 6. So I'm going to say 8 divided by 6 leaves me with 3. 24 divided by 6 is equal to 4, and 30 divided by 6 is equal to 5. Is it a right angle? Well, the 5 is the diagonal, 4 and 3 are the 2 legs. Is it right? Yes. It follows the Pythagorean triple. If we look at the next one here, we have 12, 16, and 22. So looking at it, let's see what we can reduce. I can see here that I can divide them all by 2. So divide that one by 2, and I'm left with 6. Divide 16 by 2, and I'm left with 8. 22 divided by 2 leaves me with 11. I can't reduce anymore. It is not a 3, 4, 5 ratio. So no, this does not have a right angle. The next one, we have 1.5, 2, and 2.5. Well, comparing things when you have decimals is a bit of a pain. So let's get rid of the decimal. We double each of these. Just make sure whatever you do to one ratio, you do the other. So I'm going to multiply each by 2. So 1.5 times 2 gives me 3. 2 times 2 is 4. 2.5 times 2 is 5. I now don't have any decimals, and I also have the Pythagorean theorem triple that we're looking for. So we have a 3, 4, 5 ratio. So yes, this one would be a right angle. And for the next one, we have a 9, 12, and 15. I'm going to divide each by 3. And 9 divided by 3 gives me 3. 12 divided by 3 leaves us with 4, and 15 divided by 3 leaves me with 5. So this one again has a right angle. So just simple, just figuring out what are the ratios, taking us really back to quite early in our semester. All right, so that's how you use a Pythagorean triple. So if you're just given the length of 3 sides and they want to know, does it have a right angle? All you have to look for is, do they make a 3, 4, 5 ratio? Now let's go on to actually working with our equation and rearranging a little bit. So I want to find out what is the length of the hypotenuse in this particular figure. We're going to round the answer to the nearest thousand. So when I want to know what is the length of this side, so this is my hypotenuse, here's my right angle, and I apologize if it's not always marked clearly in the slides. We'll try add it in. It's one of the disadvantages to having to write your own text. So this is my C, and let me get some better color. So this side is my C, okay, for the hypotenuse. So we need to know what the equation is. Now the equation for Pythagorean theorem is something you want to memorize. So a squared plus b squared equals c squared. If you don't have that memorized, put it on a cue card somewhere, stick it on a sticky note, post it by your computer. I want you to work at memorizing that. That's something that you won't be given on a block exam, but you would be expected to know. So how do I solve for this? So let's label one side, let's label, say this side is A, we'll call this one B. So we're just going to simply fill in the information. And it's quite easy to solve. For this particular version of the equation, I want to make sure you're using your calculator properly. Sorry for the shuffling papers. So the first thing we're going to do is put in our information, 1.254 squared plus 1.365 squared equals c squared. Okay, so there's our equation. Now we need to solve it. So when you're putting it in your calculator, especially if you're using a calculator that's the recommended calculator, you need to find your squared button. It's the third button in past the shift on the top row. So you are going to, in terms of keystrokes, 1.254, press your squared button, plus 1.365, press your squared button, and make sure you press equals. That pressing equals is going to matter. If you don't press equals, it will just tell you the square of this number. Okay, so it's really important to press equals. When you have correctly solved that, you will have that 3.4357 equals c squared. Note, you cannot do 1.254 plus 1.365 and then do your squared. That's not going to give you the same thing. You need to do the squareds each separately. Your calculator will keep track of order of operations if you put it in exactly the way it's written in this number. Just make sure at the end you press equals. So now that we have this, hopefully you got that value. If you didn't get that value, I would like you to do a virtual check-in with me. Schedule just a couple minutes or send me a quick message and let me know so that I can make sure you're using the tool correctly. Now that we have this, so I've kept one extra decimal place, and that's just so I'm going to get a little more accuracy when I round to the nearest thousand. Now this is equal to c squared, which is not c, so I need to know how do I figure out c. So I'm going to take the square root of both sides. Okay. When I take the square root of both sides, it undoes the square on the c. 3.4357, press shift and square root on your press the square root button on your calculator, and you will find that it turns into 1.854 inches. So that gives you all of that information. So let me know if for some reason you're not getting that. We're going to do another example that has this, that does exactly the same format. But let me know if you're not getting those values, because it's just going to be a calculator thing. Make sure at the end you're always taking your square root. You will always need to do that with Pythagorean theorem. Now let's go on to the next one. In this one, I want to again find the height of the triangle, or I want to find another side. So the height is straight up from the base. So here's my right angle, and this is my height. Okay, so we're going to use Pythagorean theorem. Get a habit of writing it down. It'll help you remember it. A squared plus b squared equals c squared. So I'm going to call this A, I'll call this one B, and I'll call this one C. Okay, so a squared plus 26 squared equals 45 squared. In this one, you'll notice A is not alone, so we have to use that algebra skills that we used our last semester. So we need to move 26 squared over to the side with the other number squared. So we just subtract it, minus 26 squared. Now you may not always write that step down, because if you're looking for a side that's not our hypotenuse, not the longest side, it's always going to be whatever that side label is will be equal to the hypotenuse squared minus the side that you know squared. Okay, so you'll always find it happens to end up with this formula. Now again, you can do this in your calculator in one step. 45 squared minus 26 squared, press equals. Okay, make sure you press equal. So take a minute, pop that in your calculator. You should get 1,349 equals a squared. And then we're going to take our square root. A equals, we should get 37. We put millimeters in, so we're going to get millimeters out. There's our answer. Again, if you're not getting that solution or you think there's an error, please contact me and let me know. It's really important. So we just learned two methods of using Pythagorean theorem. We're going to practice them using two more examples. So again, write down your Pythagorean theorem somewhere. And hopefully you'll write it down enough times today that if you don't have it memorized, you will. So a squared plus b squared equals c squared. So there's our formula that we're using. So if I come over here, here's my right angle. So that means this side is C. Let's call this one A. Call this one B. So we'll deal with the green triangle first. We'll deal with the other one after. So using Pythagorean theorem, we don't know A, so we're going to just leave that. Plus 0.239 squared equals 0.389 squared. Now, one of the reasons for putting things in your calculator all in one step is the more digits we have, the longer the number is that we need to carry in our calculator. So learning to put it in all in one step rather than finding out what are the squareds and then moving them after will just save you writing things down, will save you error. So again, let's rearrange. We're looking for this a squared, so that means this is the one where you do the subtraction. Okay, make sure we're just going to write it this way, and we're going to actually write it the long way. Make sure in your calculator you're doing 0.389 squared. Don't subtract these two numbers without including that squared. Okay, you can't just subtract them. You have to square first. So we really end up with this a squared equals 0.389 squared minus 0.239 squared. A squared, now take a minute, put that in your calculator, make sure you get the same value. We'll find a squared equals 0.0942. So the numbers are going to get quite small. You'll have a lot of digits to carry, especially when we are dealing with decimals. And then because that's a squared, we have to take our square root on both sides. So a is equal to, and when you do the square root of a decimal, if it's something smaller than 1, the number gets larger. It's kind of one of those weird things. It seems counterintuitive, but the number will get larger. We're going to get 307, whoops, inches. Decimal 3 zeros. Let me just erase here. Every once in a while, PowerPoint thinks it knows what I want to do and doesn't follow through. 0.307 inches. There's your answer. Okay, so not overly difficult, just that little bit of rearranging in the middle. Now we're going to finish the one that's easier. So this one, again, we want to find out what's the missing side. So there's the hypotenuse because this is the right angle. Now we have our two sides. We'll still say vertical is A. And this one's B. Now we can rearrange these triangles. They could be rotated, so watch for rotation. In the worksheet, you'll get some rotation. It'll give you a good chance to watch for that. So to solve this one, a squared plus b squared equals c squared. 7.89 squared plus 2.65 squared equals c squared. Add these two together. 69.275 equals c squared. Now you're going to take your square root. Square root both sides. Okay, and you will find you get 8.32 inches equals c. There's your final answer. So they're not terribly complicated. There's only two versions. You're either going to write a squared plus b squared equals c squared, or you'll end up with a version where a squared equals c squared minus b squared. You could move the a and the b. The a and the b could flip locations, but those are the two versions you want to. If you don't like rearranging and you really want to memorize it, I would love to see you just memorize a squared plus b squared equals c squared and do the rearranging. Now I do have two other questions, and the two other questions just get us, and I don't put a lot of practice on these ones, but they get us to look at what about when it doesn't look like a right angle. We're going to spend the entire lesson. Next lesson is just going to be dealing with these. I just need to go pick up a book at school to finish off the lesson. So we'll get that done up today, hopefully. So we're looking for these. You'll notice that this triangle is not a right triangle, which would mean we can't use Pythagorean theorem because Pythagorean theorem only works with right triangle. But I'm going to show you how the triangle will break down to give us a right triangle, and it's going to give us a nice little launch. So once you get through this, if you understand what's happening in this question, give yourself a little pause, give yourself what I call a day of soak time for that to kind of sink in, and then come back and finish, do the next lesson. It's going to have more of these finding the right angle. So this question says an equilateral triangle has a side length of 3.45 inches. What's the height of the triangle to the nearest hundredth? So an equilateral means all sides are equal, as you learned in your last lesson. So this is 3.45, 3.45, and 3.5. What this question is looking for is the triangle height. So if we go straight up the middle, what's that going to be? So you can see as we do this that we're already starting to get what looks like a right angle. Because if I do my base and my height are always at right angles to each other, if I just look at this half of the triangle, I can figure out the height. So what I'll often do, and it's partially to help simplify things, is I draw my right angle. Now the diagonal is the 3.45 inches. Height is what I'm looking for, so I'm going to throw an X there. And now I need to know what's the bottom. Well, it happens to divide this triangle in two. So 3.45 divided by 2 leaves us with 1.725. So that's this one. So this is the triangle that we're solving, and by solving this half the triangle, it will actually give us the information we want to know about the whole triangle. So how do we find X? Well, X, this is, let's change its name. Let's call it A. Let's call it A instead, just because it lines up with this. We can see this one's a hypotenuse, and this one will be our B. This one might be a little trickier for some of you. If it is, just bear with me. You'll get another lesson and practice on it before you have to do a lot with it. All right, so we have A, B, and C. So our equation says that a squared plus b squared equals c squared. We don't know what a is, so we're going to leave that. Plus 1.725 squared equals 3.45 squared. Now we rearrange. We're moving that to b. Okay, moving to 1.725. So a squared is equal to 3.45 squared minus 1.725 squared. And if you put that into your calculator correctly, make sure you press the equals at the end of it. So 3.45, press your squared button, minus 1.725, press your squared button, and then hit equals. Make sure you hit that equals. You should get 8.926. Now, when I say we're pressing the equals, that's especially important if you have the calculator that is for block release. I do have a second calculator that's my favorite for doing calculations. In that one, I do not have to press an equals again. So you do have to know your calculator. If you're not sure what you have for a calculator, please do put I was going to say FaceTime, but a quick virtual session with me. Let me know when I'll set one up. So a squared equals 8.926, and then we just take our square root because we want just a, we don't want a squared. So a squared is equal to 2.99 inches, which equals the height. And I, of course, rounded that. Okay? So that solves the question. It's not a complicated question. The trickiest part was figuring out what's the right angle. I have one more that has that. This one, I think you'll have, there's an example of an example. So you'll see exactly how to do it before you have to try it on your own. This one wants to know what's the perimeter of the trapezoid. So you might want the perimeter of the trapezoid. Sometimes they'll ask you for a length of the side. There's a couple of different ways we can ask. It says assume the lower angles on each side are equal. So what that does is when we say these two corners are equal, that means that this side and this side are the same length and that it's symmetrical. So it makes it so we can divide. So first of all, we need to find the triangles. Well, this one I think is fairly obvious. If we break it out straight down the edge, we get two triangles that are identical because they share angles that are right triangles. So if I can just find the length of this side, there's my C, I can figure out the perimeter of the triangle. But in order to do that, I also need to know the base. So I'm going to do like we did before, just to get rid of some numbers. I'll call this my C. We know that the height is 20 because it's 20 in the middle. And we need to calculate, well, what's the bottom here? So what's this? So to calculate that edge, we're going to take 42 and we're going to subtract 26. 42 minus 26. Make sure I calculated everything right because I have a feeling. Oh, it is right. Just making sure that. So you get 16, and then we have to divide that between the two sides. Divided by 2 gives me 8. Okay, so this edge is 8. And then over here, this edge is also 8. Putting that into our little triangle, we get 28 and C. We want to find out, well, what's C? A squared plus B squared equals C squared. A squared, we'll say 20 squared plus 8 squared equals C squared. Putting those two into your calculator, and let me turn to the page that has the notes all solved. You will get 464 equals C squared. Take the square root of each side. C is equal to 21.5 millimeters. And rounding to a whole number, because the rest are all in whole numbers, will leave us with 22 millimeters. Okay, that's C, but that's not our final answer. The final answer said, what was the perimeter? So to find the perimeter, I need to just add all the sides together. So the perimeter is equal to 22 times 2, because we've got two sides with that, plus I've got a 26 plus 42. In total, that would be a perimeter of 112 millimeters. Okay. So not overly complicated, relatively straightforward. Next day, we'll look at figuring out what are some distances if you have an optimum. And in particular, that's like when you're looking at nuts, bolts, those kinds of things are scenarios where we might use them. So we'll look at a few more applications for where we find them on parts. I just have to go pick up some parts diagrams. So just as a quick recap, a triangle's hypotenuse is always opposite the right angle. If it doesn't have a right angle, it doesn't have a hypotenuse. Pythagorean theorem can only be used with right triangles. It's really important. And A and B are always the triangle legs, with C always the hypotenuse. Non-right triangles may break down to right triangles if enough information is given. So you saw a couple examples where we had things that didn't look like they were right triangles, but we were able to generate a right triangle from them and use it to solve. So we're going to do a lot more next day, or next lesson is really going to focus on this, because lots of times we can use Pythagorean theorem in places that it doesn't look like it. All right, so that finishes off your lesson.